Let's talk about bonding atoms. What exactly is a chemical bond? A chemical bond is an attractive force between opposite charges. It's attractive, meaning that it is something that pulls things together rather than pushes them apart. And the thing that we refer to as a bond is actually a force, an electrostatic force. And we've already met Coulomb's law, learning about how salts bond. When these opposite charges are attracted to each other with this force, that creates a new pure substance. And we already know that there are two types. There's elements that we've studied in their atoms, but now we're looking at the one that's more complicated, the compounds. Remember that things that have charges are things like electrons and protons that are attracted to each other within an atom, and also between other atoms, as we'll learn in our new type of bonding. We've already looked at the attractive charges between ions, cations to anions, when we studied the formation of salts. Why is it that bonds form? What's causing all of this? Bonds form to increase stability. And the stability we're looking at is the stability of the electron arrangements, having a full valence level with 8 electrons in the s and p sublevels make an atom more stable. And it can often do this by gaining and losing electrons. But in other cases, there's not enough electrons to gain or lose, and they work out another way to get electron stability by sharing electrons. Another reason bonds form is to decrease chemical potential energy. The lowering of chemical potential means that we don't have energy stored in the atom. It's released to the environment. And that release of energy often comes by changing how your electrons are arranged, by reaching that full octet, by having different attractive forces change the distance from the nucleus an electron might be experiencing. And we already know that the distance from the nucleus is associated with energy when we studied energy levels. Now, let's talk about how bonds form. Our focus now will be on covalent bonding, as we've already studied ionic bonding. When we studied ionic bonding, you know that atoms have gained or lost their electrons so they can complete their octet, and then once they're charged particles, they're attracted to each other through electrostatic force, and that electrostatic force is governed mathematically by Coulomb's law, and it works between ions, and we call the thing that we get a formula unit of a salt. That's the pairing of cation and anion in their simplest whole number ratio. For covalent bonding, our atoms are neutral. They haven't gained or lost electrons, so they're not charged. And these neutral atoms share their electrons with each other in order to complete their octets. And this sharing lowers the energy of the electron arrangement, and that gives them greater stability. Remember, get stability in your electrons, release chemical potential energy, and this is an energy lowering process, and it's a much better situation than if they were just remained alone individual atoms. Covalent bonding is how our 7 diatomic elements come about. They have a greater chemical stability to complete their electron arrangement and lower their chemical potential energy by pairing up. This happens between atoms of nonmetals, and the particle that we say is formed is called a molecule.